All right, so our third speaker is Jeremy Renshaw. He's a senior technical executive at Electric Power Research Institute. He leads EPRI's efforts for artificial intelligence, quantum, and nuclear innovation focused on accelerating innovation across these disciplines in the energy industry and building connections between the energy industry, academia, government researchers, and technology providers. Prior to this, he managed EPRI's used fuel and high-level waste group and was a project manager in EPRI's non-destructive evaluation program. He has a PhD in materials science and engineering from Iowa State University, and I won't give any spoilers away. I've seen Jeremy's slides. The nerd in me got very excited. There's some really cool cutting-edge stuff that they're doing in EPRI, and we're excited to learn more from you. So thanks, Jeremy.
All right, thank you very much. All right, I will not be standing behind this because I will be like a caged animal that poses no threats because I have nothing dangerous. No claws, no teeth, nothing. So I want to start out with a bit of a question. So who here is a student? All right, very good. Of you students, who eventually wants to get a job? Not all of them. So, okay, so some of them are, I guess, independently wealthy. I guess this is Duke, so very nice. You can just go straight into retirement. So those of you who do want a job, who wants to make a difference in the world? A positive difference, sorry, not just a difference, a positive. Okay, so all of those who want a job wants to make a positive difference. So we're going to talk a little bit today about how artificial intelligence and energy can make a positive difference in the world. And hopefully I'll wrap up with how you can also get involved to make a positive difference. So I want to start out a little bit. So Evan talked earlier about how the Sloan Foundation will fund basic research so we can bring in Kyle and Trey, and they can do some great, wonderful work. And then they come up with these great studies that we need to get out into the field. So where EPRI comes in, we're a nonprofit research institute focused on applied research. So we like to partner with universities, national labs, startups, to take these concepts that have been studied and tested and developed at these very high-class institutions, whether it's Duke, MIT, Stanford, you name it. We like to get with you and scale them up in a way that then they can be applied at a place like Duke Energy. So take it from Duke University to Duke Energy and other utilities, energy companies, to be able to make those positive differences in the world. So what I'll be talking about is really 3 use cases focused around energy where AI plays a role. So we're not doing AI for the sake of AI because it's a buzzword. We've been doing it for many years. We have ramped up recently similar to others, but what we're doing is trying to be that bridge over the valley of death from the early TRL stages to the late ones and be that partner who works with everyone. We really have no competitors because we're a nonprofit. We're just trying to help the energy industry to be better. So we're doing this for AI in really 3 areas. You can see those at the top. We're trying to build an AI and energy community. We're doing this similar to the EIA talked about earlier, bringing together data. So we're bringing together data, solutions, and trying to find ways that we can work together and partner for the benefit of all. And third, we're trying to deepen energy industry expertise in AI and vice versa, AI expertise in energy. So big thanks to Kyle and Trey for putting this together. This exactly fits with where we want to be and where we want to be engaged. So we're doing this through a series of grand challenges. You can see those at the bottom. I'm not going to go into those in the interest of time. Often I speak for half an hour to an hour and a half, so you don't want me to go into the full spiel. If you want to eat lunch, if you don't want to eat lunch, I'll stay after, we can talk. So I do want to get into a few use cases. So the first one revolves around drones and AI. So drones, very cool technology, but how can we actually use them? Similar to many technologies, they floundered for a while because there weren't valid use cases. So what we're looking to do within the energy industry is take advantage of the additional capability that drones provide. And I have a little video that plays here that shows what exactly we can do on the transmission and distribution infrastructure, where we can put an automated flight plan in, take a large number of images of the transmission and distribution infrastructure. So you say, well, why do I care about that? Well, we use these images to identify degraded components. So our transmission and distribution infrastructure around the United States and around the world is approaching end of life or at end of life. And it's very expensive to replace. So we would like to be able to use it as long as possible to be able to keep the lights on without spending a fortune. So we're using drones to be able to collect more images faster, more economically. But the ability to take more images doesn't mean anything if you can't analyze those images. So now a utility like Duke can take hundreds of thousands of images. And so they have vast tomes of data to comb through. Well, now you can either hire many, many people to go through and analyze those images, which is fun for about an hour. But if that is your entire job day in and day out for years and years and years, you get very tired of looking at the same images, vastly of just components that are all good and very infrequently components that have degraded. So this is a key use case for artificial intelligence because it doesn't get tired, it doesn't get bored, it doesn't care if you throw 100,000 images at it, it will just chug through and analyze those for you. So what we're doing at EPRI is bringing together vast quantities of images as well as labeling many of them. So if you look here, we're pulling together, at this point in time, we have about 150,000 images that we've brought together that are available for free to the public. So it's a multi-million-dollar data set that is available to all of you for free. So there's a QR code there if you want to go to it and download those. We also have our website is ai.epri.com, so you can go there. It'll get you there as well. So we are trying to build this into a database of many hundreds of thousands of images, maybe even 1 million images, so that then you can train AI algorithms to go in and help utilities to be able to analyze these images much, much faster. So obviously we're not done yet. We have some data sets that are coming. So you saw the previous image of all the ones that we've released. We have significantly more that are coming out as we continue this effort. So we're working with utilities from around the world, not just here in the US, to be able to bring these data sets together and share them for free. Obviously there's a lot that goes into that in terms of taking out personally identifiable information. Let's say there's a mailbox or something that's in an image, we need to blank that out, or there's a person walking through, we need to blur their face, different things like that. So there's a lot that goes into this. So that is one of our EPRI 10 data sets that we're releasing. So that's the one you can see highlighted here. We have 10 other of what we're calling the most valuable data sets in the energy industry that we're bringing together to try and release as possible into the wild. So moving forward, now we're going to talk about a really interesting project that kind of ties into what Sean talked about earlier with AMI data on the grid. So now we're looking kind of holistically at the grid of how can we use AI to manage the grid. So if we look at the US power grid, it has often been described as the most complex machine that humanity has ever built. So that's a bold statement. It is also incredibly difficult to optimize the most powerful or the most complex machine ever built. So as you pull together grid-connected components in a network, the complexity exponentially increases with additional components. So this already incredibly complex machine is incredibly difficult to operate. Luckily, we have wonderful utilities around the world that have power system operators that focus on exactly that. But it's still very complex and absolutely not fully optimized because it is far beyond the complexity or the computational power of even today's exascale computers. So you have Frontier, Summit, off at Oak Ridge National Lab. You could plug them away for as long as you want and they will not be able to optimize the power grid. It is just too complex. So what are we doing to be able to help? And we is not just EPRI, it's RTE, Google Research, IQT Labs, University College London, and others. We're really trying to pull together the data in a format that we can use to solve this challenge. So the way that we're going about this is using reinforcement learning. So it's essentially a gamified system, and I'll skip forward in the interest of time. So we have a gamified system that understands the physics of a network in terms of what causes a brownout, a blackout, voltage sags, voltage spikes, things like that. And then you apply different conditions to that power network. In this case, it's a very simplified one with just a few nodes and connections. But you can imagine this can scale up. And we're using the same type of reinforcement learning algorithms that were used with Google's AlphaGo, which I think people are aware of. That was Google's system that played the game of Go, the most complex board game by most measures. And that system became so powerful that it beat Lee Sedol, the 19-time world Go champion. So best player in the world, beat him. However, Google's AlphaGo only understands the game of Go. You would beat it at a game of tic-tac-toe. You would beat a supercomputer using this system at a game of tic-tac-toe. So it only knows what it knows. It does not know what it doesn't know. And that's where the complexity comes in for a power grid. So the reinforcement learning algorithms will go through, and they can go through hundreds of millions of scenarios, but if it sees a new one that is completely different from something that it has seen before, it won't necessarily know how to react. And that's why we're looking at this right now as a decision support agent. So we're not saying, let's train this algorithm up and put it on the grid, because let's do a quick study just here in the room. Who thinks 99% reliability is great? A few. Sean, how about 99% power reliability?
After last Christmas, 100%.
I would put forward that 99% reliability is an abysmal failure. Yep. That means every day your lights are off for 15 minutes. I was in South Africa a few years ago where they do load shedding for 6 hours at a time. Anyone like to have their power off for 6 hours at a time? That'd be pretty awful, right? Well, that's what they're going through in South Africa. And we want to make sure that as we train these reinforcement learning algorithms, we give them sufficient data to be able to understand how a power network operates. So as we scale these up with our partners, we've seen vastly new and different strategies that the algorithms have come up for operating a power network. But every now and then you'll see that they're not quite there, they're not quite ready for prime time. So this is something we see as still a few years away, but a very exciting development within reinforcement learning for automating a power grid. And we see a lot of connections where quantum computing could really help to accelerate this process as well, but we won't get into that here. All right, and the third use case I want to touch on is satellite imagery. So again, what we're trying to do is bring together these new emerging technologies when they make sense and pair them together for mutual benefit. So satellite imagery, the exciting thing about this is that over the years, about every decade, the cost of obtaining satellite images goes down by about a factor of 10. So while satellite imagery is still expensive today, 10 years from now, it'll be 1/10 that, and if trends continue, which they may break down at some point, it could be 1% 20 years from now of the cost that it is today. So we see a lot of value in being able to bring together satellite data. And this is why. So for vegetation management, so if we look at some satellite data and then we parse over this multispectral satellite data that we can gather today with satellites, we can overlay that in an area and we can use artificial intelligence to analyze this multispectral data to identify areas of dead and dying trees so that a utility can go out and proactively cut them down so they won't fall onto a power line. So this improves reliability, it improves safety, and it reduces costs because we're doing it automatically. Now, what EPRI has done as part of this is we've bought about $100,000 worth of satellite imagery. We've also made that available for free to anyone who wants it. So you can, again, go to ai.epri.com. I don't have the QR code here, but you can go to ai.epri.com and we can get you in contact with the people who have that data to be able to give it to you. So in addition to the vegetation management use case here, we also have some that are looking at the western states of the US where we have lots of droughts and recently wildfires, looking at wildfire risk evaluation. So how can we use this satellite data? And when I'm talking about multispectral, I'm talking about UV, infrared, and visible wavelengths of light. So beyond what just our eyes can see, because a lot of times the data we're really looking for that says, hey, this area is at risk of wildfire or this tree is dead is outside of our spectral vision band. So we use this multispectral or hyperspectral data to be able to go in and get better information on that. So those are the three use cases that I want to talk about. Basically, the bottom line is we at EPRI are trying to bring together the AI and energy communities. We're very grateful again to Duke for putting this together, as well as Wisconsin and all of your other collaborators. We see the AI as a force multiplier in the energy industry of being able to add on to things that we're doing to be safer, more reliable, more efficient, and provide environmentally responsible energy to the world. So if you want to learn more, go to ai.epre.com. Come catch me afterwards. I would love to talk more. And with that, I'll turn it back over.